Okay, this lesson is about CPCTC, which stands for corresponding parts of congruent triangles are congruent. So if we know that triangle A is congruent to triangle B, then we know that this angle is congruent, and this angle is congruent, and this angle is congruent to this angle, and the sides too. So CPCTC is a shorthanded version. You cannot use CPCT until you prove the triangles are congruent. So CPCTC is used when you are trying to prove parts of triangles are congruent. So the steps are, first you have to prove the triangles are congruent, then you can prove the last line that the segments are congruent. I know number one is CPCTC because we're proving that two segments are congruent. So I'm going to write the given. So I'm writing the given in, and now I'm going to mark it. Angle Q is congruent to angle R. Angle QPS is congruent to angle RSP. Okay, so I have my given in, and I want to look for side, 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 angle, side, angle, or angle, angle, side. So far I only have two angles, but I do know that PS is congruent to PS by reflexive. So now I have two angles and two sides that are congruent. So I can say triangle PQS is congruent to, now be careful, your P corresponds with S down here. So it's S, and then Q corresponds with R, and then P. By angle, angle, side. So now I've proven the triangles are congruent. Now I can prove that the sides are congruent. So I can say that SQ is congruent to the segment PR by CPCTC. So you need to do the triangles are congruent, and then you can do CPCTC. Okay, for the first one I wrote the given in, and if you know that C is the midpoint of AE, you can mark that these two are congruent. So I know that AC is congruent to CE by definition of midpoint. I can also do the second one, which is C is the midpoint of, this actually should say BD. So I can also mark these two. So this is BC is congruent to CD by definition of midpoint as well. So now if I look at my triangles, I have just two sides. Remember, I need to have side, 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 angle, side, angle, angle, side, or angle, side, angle. But I have that these two angles are vertical, so instead of writing angle C, I need to write angle CAB is congruent to angle D, or ACB is congruent to DCE by the vertical angle theorem. So I have enough now to say these two triangles are congruent. These two triangles are congruent by side, angle, side. So I'm going to say triangle DEC is congruent to triangle D matches up with B. And then E matches up with A, and then C by side, angle, side. So once I prove the triangles are congruent, I can now, as a last line, say or write that AB is congruent to DE by CPCTC. Now down here I also wrote the givens in, so now I'm going to mark them. So if CB bisects angle ACD, it means that angle BCA is congruent to angle BCD by definition of angle bisector. And I also have to mark the second one, which is AC is congruent to DC. And now they share a side, so I can write BC is congruent to BC by reflexive. And so now I have side angle side. So I do triangle BCA is congruent to triangle DCB by side angle side. So therefore, I can say that angle A is congruent to angle D by CPCTC. Okay, so I wrote out my my three givens actually. So now I'm going to do something with them. I'm going to mark the perpendiculars. So I can say that angle B is congruent to angle D by the theorem that says that right angles are congruent. You could also, some books and online, it could say that since they're perpendicular, you probably should add in, or you could add in, I don't care if you just go right to the right angles are congruent, but you could add in that they are right angles by definition of perpendicular. Now I'm going to mark my second one. BC is congruent to CD by that's given. And now I need to look at what my diagram, what I have to work with. But I know that these two angles are congruent. These two angles are congruent by vertical angles. So I can say, instead of writing angle C is congruent to angle C, I'm going to write angle BCA is congruent to angle ECD by the vertical angle theorem. So now I can say the two triangles are congruent. Triangle CBA is congruent to triangle C. B matches up with D and then E by angle side angle. So now once the two triangles are congruent, I can show that the two angles are congruent by CPCTC. Triangles first and then prove the CPCTC. Okay, I wrote out my given. Now I'm going to mark them. So FG is congruent to GH. Angle JFH is congruent to angle GFH. GHF. So one other thing I know is that JG is congruent to JG. And that's by reflexive. So I'm actually at a standstill right here. This one can't be done because this is not a theorem. This is a side angle situation, and we don't have that. So I'm thinking, I bet this was probably meant to be FJ. I bet this was meant to be parallel because then you'd have alternate interior angles, but I can't assume that, so you cannot prove this because we need more information because there's no side angle. Okay, I'm writing the given for this last one. So if I know that JH is parallel, this is a transversal between two parallel lines, and this is a transversal between two parallel lines. So I can say that angle J is congruent to angle L by the alternate interior angles theorem, which says that if you have two parallel lines cut by a transversal, the alternate interior angles are congruent. I can also say that angle H is congruent to angle M for the same reasons by the alternate interior angles theorem. And we already know that JK is congruent to KL by given. So I could do vertical angles too, but I already have enough information. So I can say that the triangle JKH is congruent to the triangle J matches up with L, matches up with K, and then H matches up with M by, this would be by angle side. So therefore, my last line is KH is congruent to KM by CPCTC. So you have to do the triangle, and at the end you prove the side lengths. Make sure that you are writing this statement right here correctly, that the J corresponds with the L and the K corresponds with the K. So be careful about that.